Okay, so in this video, let's understand what column standardization is and why is it important. Let's say I have a data set D, which has just two features, F1 and F2, all right? Um, yeah, so it just has two features. Let's say that F1 is a feature where the range of values varies between 0 and 100. And F2 is a feature where the range of values varies between 0 and 1, right? So let's say I have three data points, x1, where the feature 1 value is, let's say, 20, and the feature 2 value is 0.2. Okay. I have another point, x2, where the feature is 25, and this is 0.2. And then I have a data point, x3, where the feature is 20, and this is 1. Right. So if I take something like a distance measure, like a Euclidean distance, or let's say, uh, you know, some distance measure between, let's say, x1 and x2, I would get the value over here as 5, right? And this is simple Euclidean distance. And if I take the distance between x1 and x3, I would get the value as 0.8, correct? So now if I had to compare these data points on the Euclidean distance alone, it looks like x1 and x3 are more similar to x1 and x2, right? Because they have a smaller distance. But if you look at it this way, you see that the difference in the features of x1 and x3 is just 0.8 on 1. Similarly, the difference over here between x1 and x2 for feature 1 is 25 minus 20 upon 100, because the range of values is 100. So this is 5 by 100. This is 1 by 20. Okay. So where I have over here is 0.8 upon 1 is like 4 by 5, right? And this is 1 by 20. So obviously the distance varies a lot more when you have 0.2 and 1, correct? The difference varies a lot more. But when we use something like Euclidean distance, it doesn't seem to take the variability of feature 2 into consideration when feature 1 is also used, because the difference in the values of feature 1 overpowers that of feature 2. So what we do is there's something called column standardization, where you just standardize the columns, which is the feature 1 and feature 2 values, to a range of 0 and 1, so that it's easier to compare different data points in a data set. How you do that is you take, so let's say for every data point a in uh, every data point, uh, x1, x2, x3, let's say I have a feature in a I have a data point in feature 1, and I want to convert this into a dash, which is my new data set. So how I would do it, I would take the value of that particular column or that particular value in uh, a dash would be given by a minus mu upon sigma, right? What is mu? Mu is the mean of all the feature ones, and sigma is the standard deviation of all the feature ones. Similarly, if I have to take for feature 2, and if that point is called b, I would call it as b dash equals b minus mu upon sigma. This is mu1. Let's call this mu1 sigma 1, mu2 sigma 2. What is mu2? Mu2 is the mean of all the values of feature 2, and sigma 2 is the standard deviation of all the values of feature 2. So that's how you transform your data set uh, into the similar range of values so that they can be compared in a better manner. Now, column standardization is usually used when you have a data set and features that are normally distributed. In case your features are not normally distributed, you can still use standardization, but in case they're not normally distributed, you go with something called normalization. Okay. Normalization, what normalization does is so a dash will be given by a minus a min upon a max minus a min. Okay. where A min, A max, A min are the maximum and minimum values of feature 1 and feature 2 respectively, and A is the particular point in feature 1 or feature 2. So this gives you a value between zero point 0.1 only. Okay, so column standardization and column normalization are two ways to transform your data set if you're using distance measures to compare your data points.